Okay, so at this point we have gone over four periodic trends. We've gone over atomic radius, ionization energy, electronegativity, and ion size. So let's kind of put it all together, put it on one kind of picture to look at, and then let's try doing some problems and kind of stuff that you're going to have to be able to do for this unit. So here's our overall trend, periodic table. So we have the atomic radii. Remember, so as you go from left to right, the radius gets smaller because there's more protons pulling on the electrons. So left to right, the atomic radius goes down. But as you go from top to bottom, it increases because you're adding more layers. Every time you go down a row, you have an additional layer of electrons, which makes it bigger. Okay. Ionic radius is the same idea as the atomic radius. So as you go down, you are getting more and more layers, so they get bigger and bigger. As you go left to right, the overall trend is that it decreases, but you got to remember the difference between the cations and the anions. That happens right here. So the cations get smaller, and then you have a point where it jumps up in size for the anions, but then they start getting smaller as you continue to the right. So it's the overall trend is decreasing, even if there is a point where it increases. Okay, then you have ionization energy. Ionization energy is the amount of energy it takes to take an electron from an atom. So as you go down the periodic table, the ionization energy decreases because you're getting bigger and bigger. So you have bigger and bigger atoms. Bigger and bigger atoms are easier to take electrons from. Okay, but as you go from left to right, the ionization energy increases because the atoms are getting smaller. It takes way more energy to take an electron from a smaller atom. Okay, and then we have electronegativity. As you go down, the electronegativity decreases again because as you go down, the atoms get bigger. So the electrons, the nucleus is further and further away from the electrons on the outermost side, so they can't pull as hard. While as you go from left to right, the electronegativity increases because the atoms are getting smaller and they want more and more electrons to become like noble gases, so they really attract electrons. So you have to remember though with electronegativity that the noble gases have no electronegativity because they are stable. Okay, so those are our four trends. Now let's talk about them. Okay, so let's practice this now. We have carbon. We're talking about increasing atomic radius. So we have to start with the smallest guy. So we have carbon, we have oxygen, we have aluminum, and we have potassium. Okay, so who's smallest? Well, remember, atomic radius as you go from left to right decreases, and it increases as you go from top to bottom. So that means stuff over in the upper right-hand side of the periodic table are going to be smallest. So that means oxygen is probably going to be the smallest, and then carbon. And so even though carbon and aluminum are close to each other, aluminum is the next layer down. So it means it's going to be bigger. And then potassium is not only the next layer down, but it's also way, way, way over on the left-hand side. That means potassium is going to be the biggest. So increasing atomic radius, oxygen is smallest, then carbon, then aluminum, then potassium. Okay, next we have electronegativity. So we want to go by increasing electronegativity. So we want to start with the lowest electronegativity. And so we have sulfur, oxygen, neon, and aluminum. Okay, so the lowest electronegativity, where it's like, all right, so what's the trend for electronegativity? Electronegativity, as you go down, it decreases. So the one on the bottom should have the lowest electronegativity. As you go from right to left, left to right, it increases. So the one that's on the most on the right should have the highest electronegativity. So you'd want to go with neon, except we have to remember with electronegativity that the noble gases don't have any electronegativity because they're stable. So that means neon is the lowest electronegativity. Then we go back to our general thing. Aluminum is a metal. Metals have low electronegativity, so that's going to be the second lowest. And then you have sulfur and oxygen. So now we got to remember that electronegativity decreases as you go down. So that means sulfur has lower electronegativity than oxygen. So our final ranking is going to be neon, aluminum, sulfur, and oxygen. Okay, and now we're just going to compare two different ones. So we have lithium and beryllium, and we want to know which one has who's got the greater ionization energy. So ionization energy, remember, it increases as you go from left to right. Ionization energy is the amount of energy it takes to take an electron. So beryllium is the furthest to the right, therefore beryllium has the greater ionization energy. Okay, next we have calcium and barium. So what happens to electronegativity or ionization energy? As you go down, it decreases. So barium is way lower than calcium, even though it's in the same columns, 3 rows down. So barium is way bigger. So barium is easier to take an electron from, so it has a lower ionization energy, which means calcium has the higher ionization energy. And then finally, we have sodium and potassium. Again, this one should be which one's got the greater one? Well, sodium is, as you go down, ionization energy decreases. Therefore, because potassium is larger, so sodium is going to have the greater ionization energy. Okay, ion practice. Ion stuff gets a little bit harder because it's got that weird trend, particularly as you're going from left to right. So we have potassium and gallium. Okay, so those are both cations because they're both metals, because remember the line that divides the metals is over here. Okay. So gallium is still a metal, so it's going to be a cation. So as you go from left to right, cations get smaller. That tells you that gallium is going to be the smallest. Okay. Next, we have oxygen and fluorine. So these are both anions. But just like other anions, the trend is still decreasing as you go from left to right. So that tells you that fluorine is still going to be the smaller of the two because it's the one to the most to the right. Okay, next though we have fluorine and chlorine. So both these are all in the same column, they're both halogens. So now what's deciding? Well, the trend with ionic radius is as you go down, it increases. Because chlorine has an additional layer of electrons that fluorine doesn't have, that makes chlorine bigger. So that means fluorine is the smallest, is smaller of the two. Finally, you have chlorine and potassium. This is where you have a weird one because you have chlorine, which is an anion, and potassium, which is a cation. So normally the anions are bigger, but then you also have the fact that there's a drop in row. So potassium actually gains an additional layer. So this is one where you actually have to kind of know it. That's why I'm going over it. The difference between how much bigger those cations get, the difference between how much bigger the anions get from gaining electrons compared to gaining a row is enough that actually potassium ends up being smaller. The chlorine cation, even though the potassium's gained a whole row, that chlorine is still bigger. Okay. So these are ones where this picture, this general trend, these are the 4 trends you need to know. Ignore the fact that it says electron affinity. I don't know why that ended up on here. This one we didn't, I thought I took it off. So these are the trends: atomic radius, ionic radii, ionization energy, and electronegativity. You need to know these 4 trends, what they do left and right, and you should be able to connect it all back. And remember, it all comes back to 2 things. It comes back to the number of shells, because every time you add a layer, you add another shell. Every time you go down a period, it adds another shell. And also the number of protons. As you go from left to right, you have more protons in the nucleus. Protons in the nucleus attract electrons around the outside. And all of that has an impact on all 4 of these trends. So, good luck.